And yeah, we would like to give you an overview about different companies in Europe from the railway sector and beyond, what they are already doing with additive manufacturing. And I'm really happy to welcome Felix Spies on stage. He's the project manager supply chain development at ÖBB Technical Services, the Austrian railway company. He's located in Vienna, so we are really an international forum. He's head of AM at Technical Services and studied supply chain management. And it was really interesting. Usually he started his career in a hotel, and now he took the customer orientation into his new job. Please welcome with me Felix Spies.
Thank you. Well, how do I get from that to my presentation now? First of all, thank you, Stephanie, for inviting me. Thank you, Fira, for inviting me. I was asked by Tina 3 months ago to do a presentation here and easily said yes after our meeting that time. Then I read who is talking here throughout the day, and I got really panicked. I got even more nervous than I am now. I immediately started talking with my colleagues and asked them, well, as a railway company, how can I compete with KTM, with car industry, and so on? And the first thing that they told me was, just be on time and they love you. As a railway company, yeah, what a keynote. That's all that we are doing every day. Getting you to work, getting you on your commute on time. And additive manufacturing will have or is having a big influence on how you get to work every day. To start with my presentation, a quick input on who are we, but I'm not getting into the figures in detail. We're the smaller brother of the Deutsche Bahn. We're in Austria. That's the small country in the center of Europe who's proud of having sissy and not has any kangaroos. So just a little bit about Austria. We have 3 main application areas, which is passenger service, which is cargo, and which is infrastructure. And that's where we are doing our main applications. Me, myself, as Tina already said, or as Stephanie already said, is I'm working for the technical service. We are in charge of the maintenance. Maintenance for 35,000 rail vehicles. So we are checking that 35,000 rail vehicles are on track every day. We have 15,000 components, own components, and 85,000 components that we're handling. That makes 1.5 million parts that we're handling every year. So if we are talking about 1 to 5% within the next 10 to 20 years that there will be additive manufactured, that's a huge amount of parts. We have 150,000 orders per year. And we accept additive manufacturing to make a huge part of that within the next years. What are we doing? We're offering full solutions. So we're doing everything for the rail industry, from the fleet service management, from the component services, from upgrading and redesign, and that's like already the core business that we're doing. I'm not going to go into detail for everything on that, but from our core business, as I took over the additive manufacturing project at the beginning of this year, we are asking ourselves the questions, how can additive manufacturing really support us as ÖBB? Where are the crucial points where additive manufacturing will support us? Of course, we went through all the processes of identifying different parts and how will they affect us. Of course, we replaced missing parts. It was the first entry, and I'll show you a couple of parts that we printed so far already. Replace missing parts. Do cost reduction. A huge amount of our fleet is already 30 to 4 years old. You don't get any parts anymore for that. So there was availability for 10 to 20 years for these parts, and now we are standing in front of the big challenge that we don't get these parts, or we get them from third-party suppliers where we pay huge amounts of money to get a couple of spare parts that we need every day. We're talking about design to cost. Steffi mentioned that the rail industry is not rocket science, but still cost is a huge impact. We are operating rail cargo trains where the last container makes the difference between having a positive or negative revenues. So having cost-efficient parts there, or having even lightweight parts where you can put a little bit more, let's say a couple of more TVs into a container, that can make a difference for us and a difference for our partners. That's why, yes, design to cost and re-engineering of parts is a big deal in rail industry, and not for everybody now, but it will be in the future at least. How did we start? I said that in the beginning. It's making you on time every day. That's why we started. A piece of plastic for full availability. This is one of the parts. It's a print frame. That was one of the first parts that we printed on an FDM printer. It was not available anymore, but it's crucial. It's necessary that the locomotive is allowed to go on track again. So in the first step, we designed it, and we printed 20 pieces of that. Up to now, we're already printing 100 pieces of this print frame and built it into a 1144 fleet. This locomotive was invented at ÖBB more than 30 years ago. And now we are printing parts for it again, new parts. A battery monitoring body, same problem. Not available anymore, and we redesigned it, did a little bit more efficient for our technicians, and then we implemented it. 12 parts in the beginning. So far, it's like about 30 parts that we implemented. Heat exchanger cover in another fleet, shunting locomotive. It's funny, it's a little piece of plastic, but if this part is not available, since it's an electrical component storage, the locomotive is not allowed to go on track. I would have used a rather economic appliance and put some tape on it, so didn't work out. And after 1.5 years, sorry, the toggle switch first. And toggle switch was something that we are printing now in more serial, 10 pieces of that. That's what I want to say. A small part, a big step for us. This is our first metal part. Great outcome. The part that you see on the slide behind me was initially built from 40 different pieces. It was a huge process building it out of the train and then checking whether it's still functioning and then rebuild it into the train. It was 5 modules that were screwed on top of each other. You had to open it to get a check on whether the small parts here in the middle are still functioning, and then you had to rebuild it. Now it's one part. And the best thing of it is it's maintenance free. We made it a little bit thicker, it's a little bit re-engineered. The material we used is almost chemical resistant. And so we can build it into our trains again now, and it doesn't have to be maintained until the end of the life cycle anymore, which is 20 to 25 years for these cars. So that's the current state. Where are we now? Current status is we have identified 54 parts, and we have installed 535 pieces, 640 printed because we have some in the warehouses. We are owning 5 FDM printers, not more. We have 4 partner companies, 4 printing technologies, and 6 print locations. But that's not the crucial part. When I came into the project, I asked them, so where are we standing at additive manufacturing? I think this is the most important part that I discovered from additive manufacturing now. My colleagues told me when I entered, yeah, we are printing 300 to 400 parts, and we need to buy a new machine now because we cannot print it anymore. But printers is not everything, is it? There's way more around 3D printing that is necessary to build a strong solution for your company. And that's where we started at the beginning of this year. What's the crucial parts to additive manufacturing for you? For us, it's three very, very important things that we discovered for this year. First of all, it's the process. Do you have a sustainable process in your company of how additive manufacturing is working? From the identified part to the installed item. That was the most important thing that we worked on this year. Getting a new part, getting the idea of a new part, doing the potential analysis. Is the part really printable? Is it really a good idea to print it? Or do I get it from other technologies? Is it better? Do we have a 3D model? Do we even have a plan of it? That's the even more important thing. Or I'm scratch. How can prototyping work? And then what about testing, qualification, and certification? For us as a railway company, fire regulations is killing almost any additive manufacturing plastic project. So that's really, really strong thing. qualification and certification, getting the materials and testing. The test use itself. Do you have somebody who can do it for you, or can you do it yourself? That's for us an important thing. We are not even allowed to do all tests ourselves, and we didn't even know that ourselves, so that's good. And then at the end, what do you do when you have to have your part? How do you get the part implemented? How do you get your purchasing department to order the part? Do you have a button in your SAP that says printable, yes, no? Or how does purchasing even know that you have had a look on that part? Let me give you a quick, just a quick example of how our process is working now. And that's why we spend so much time in it. We had a part in our railjet. Railjet is our fastest train, 250 kilometers an hour. I told that on InnoTrans. Some Chinese people were laughing because their fastest train is 400 kilometers fast. So for us, it's the best train that we have. So this part is built in exactly where the arrow is. It was damaged throughout the overhaul. Through an overhaul, all of the seats that are built into our railjet have to be removed. So the part is built in down there. You don't see it. You won't see it until the end because you actually no customer sees the part because it's under a cover. But let me tell you, all seats are removed, and then the heater covers are removed. And you can't rebuild the seats until the heater covers is done. What is the part? It's the holder of the heater cover. Well, the railjet that was standing in our workshop needed to be back on track in 10 working days. So we called the company who was printing that heater cover holder and asked them if they can supply us with the part. Delivery time, 10 weeks. Problem for us. A railjet standing costs a couple of €1,000 per day for us. So how often did we use the part that we were printing within the last 5 years? 0. So how many did we have on stock? 0. Okay, we started. We started the entire process that I showed you before. From scratch to the spare part in 6 working days. That's because we have a process where everybody knows whom to contact next. Who is the responsible for testing, test use. I cannot tell you how we tested the part as long as I'm wearing a microphone, so come and ask me later on, but the test was really cool. So, the process is sustainable, it's repetitive. The product is cost saving. To be honest, the new product costs 99% less than the original part. We have 100% part availability. Yeah, because we can print this within 3 hours, I guess. We tested the spare part and it fulfills all fire rules. Actually, this part doesn't need any, so we're cheated on that. What's the second crucial thing? It's the team. Only our team made that possible. So who do we have on our project team? We have 8 project owners. So usually you can only have 1 project owner. No. Why do we have 8 project owners? We have 1 person in each of our companies. So actually the white 6 angle is finance, accounting, and controlling. I don't have a picture for that because I didn't want to copy Excel in there. We have 1 person of every team. 1 person who we asked all teams, and the persons, they announced themselves to be part of the team. So it's their team. They have motivation to work in that. They see it as a responsible for them. They get the positive feedback for that, of course, and they have motivation because we want to implement additive manufacturing that. But without them, it wouldn't work. And we have 42 project members within our companies. These project members are not direct team members, but they share information with us. They take over parts. It's like we have 13 people who are making scratches and 3D models for us. We just send a team message to them asking who has time of you to paint the part for us, and they reply and who is the fastest and who can do that for us. And at the end, this all is not possible without a network. Now Stephanie will be very happy because I'm making a little bit of a commercial for a network. We wouldn't have learned so much without having access to the network that we are in, to Mobility Goes Additive. You will see here a lot of printer companies. We could directly ask them if we had problems with either our own printers or with the technology that we have to use or with the materials that we have to use. There are other users in there. the most information you will get from other users, and you don't get easier information than having them in a network where you meet on a constant basis. Of course, there are providers, there are marketing companies, and there are consultants. Consultants can tell you a lot if they're in your project, and if you're in a network, they don't even cost you a tenth of that. So, and all of that made it possible that in now one of our core nodes from our companies, we now have additive manufacturing included. That means we service maximum functionality and maximum vehicle availability through predictive maintenance, that's one on the supply chain side, and additive manufacturing abilities. So additive manufacturing will be a standard process in us. And I was asked today in a little interview here from 3D Natives where I see additive manufacturing in 10 years. And I'm pretty sure it will be a part of a standard process, a part of every manufacturing company, not as a substitution to current technologies, but it will be an addition to it. It will solve all the problems or most of the problems that we have today. And with this sentence, I finished exactly at 0 seconds. So thank you very much. Have a nice day.